Hi, it's Mrs. Moss here. We're going to continue talking about meteorology and looking at the other weather variables. So far, we learned about relative humidity and dew point temperature. Now we're going to talk about air pressure. Now, when we talk about air pressure, what we're literally talking about is the weight of the atmosphere pushing down on us. And if we think back to our chart that we looked at the other day in the reference table that shows the layers of the atmosphere, we can see that we are down here at the bottom layer of the atmosphere and that all of these other layers are actually on top of us, and the gravity actually pulls down and is pressing on us. That's air pressure. Now, we can't feel it. We're used to it. We were born into this atmosphere at this level, so we're not adjusted to it. But if you think about it, when you go up in an airplane, your ears may pop. Or if you swim down to the bottom of a diving well in a pool, your ears may pop. This is all because you are changing the pressure by going up in altitude or even by going down into more water. So there's us at the troposphere at the very bottom layer of the atmosphere. So as we come off the surface of the Earth and go up in altitude, as our altitude increases, our pressure decreases. Now this is known as an indirect relationship, and we can verify what we're saying using our reference table chart on page 12. As we go up in altitude, we decrease the air pressure, and as I said, it's an indirect relationship. So now we have to talk about temperature and its effect on air pressure. Imagine two open containers of air, one filled with hot air and the other filled with cold air. There's the cold and there's the hot. Which one seems as if it has more pressure pressing on it? Well, you're right, it's the cold air. That has more weight pressing down on it. And you can see because they're all kind of huddled together, so it looks as if they're pressed down, those molecules in there. So the cold has higher air pressure, which tells us the lower the temperature, the higher the air pressure. What type of relationship will that be? You guessed it, it's an indirect relationship. So let's go back to these two containers, and we're going to talk about the cold air and the hot air. Again, the one on the left has the cold and the one on the right has the hot air. But if you look at the two colored dots, the red represents the air molecules. Okay, blue represents water molecules, and they're not filling up. If we were to fill this with blue, which one can hold more water? The hot air. We can fill in this more with water vapor than we can in the cold air box. So that tells us when we have more water vapor in the air, it's going to do something to that air pressure. So we said that already. But the air pressure is affected by that water vapor that can fit into that hot air. Water vapor is very light compared to dry air. So hot air, being able to fill in more water vapor into it, it actually will become lighter, and therefore it's less pressure. When you add water vapor into dry air, the air pressure will decrease. That is called humidity. Remember back to our video from the other night? When the humidity increases, our pressure will decrease. Okay, again, because the water vapor is lighter than the air. So there's less pressure when there's more water in the air. Because the air is lighter, full of water vapor, we have that indirect relationship. So two ways that we can decrease our air pressure without changing our altitude would be to increase the temperature of the air and increase the moisture content of the air. As air pressure changes are due to the unequal heating of our Earth. Okay, so because of the way we're located on Earth and on a circular sphere, a spherical shape, we'll learn more about the exact shape of the Earth in another video, we get different temperatures at different areas of our Earth. That unequal heating will cause differences in air pressure. The hotter temperatures on our planet will have the lower pressure. Now we use a barometer to measure air pressure, and we use millibars as the unit, or we also use inches of mercury as our unit. So if you go back to the reference table, it's going to be on page 13 where we saw the temperature charts. You'll see there's a column for air pressure, and we have millibars on the left, and we have every notch on that millibar that's on the left is worth 1 millibar. So we have 136, 137, 138, 139, 140. They're all worth 1. Well, on the right-hand side, we have inches of mercury, and that goes up by 0.01. So we have, if we look at this, if you look at the center, this larger line here is 30.65. So it goes up 0.01. So this would be 30.61, 30.62, 0.63, 0.64, 0.65. This is important to note on your reference table. Write it just along the top where we put it in here at this PowerPoint presentation, okay? It is important because you will be asked to convert from millibars into inches and from inches into millibars. So let's practice doing that. Convert 998 millibars to inches of mercury. So now we look on the left-hand side and we find our 998 millibars, and we look over and remember it goes up by 0.01. So the answer becomes 29.47 inches of mercury is equal to 998 millibars. Convert 1040 millibars into inches of mercury. We use the same process. We find 1040 and we go across and we see that it is 30.71 inches of mercury. Convert 996 millibars to inches of mercury. Again, going back to that chart, this time looking all the way down, we find 996. We look across, we see 29.41 inches of mercury is equal to 996 millibars. That's the end of meteorology number 2, talking about air pressure. We're actually going to get more into specific air pressure systems as we learn more about weather. Okay, but for now, we're going to stop here and we'll see you next time.